Hello everyone, my name is Srishti Yadav and I am going to give a demonstration of FIM, fault injection and mutation for Simulink. Safety critical CPS, that is cyber physical systems, must be fully operational at all times. For the fail-safe design and verification of safety aspects of such systems, researchers are relying on model-based development around the MathWorks MATLAB Simulink environment. Usually, a testing strategy is evaluated by analyzing the system behavior in abnormal situations. For this, industrial safety standards recommend fault injection and mutation testing. A mutation is an alteration of a SUT designed in Simulink by changing the behavior of the blocks or the signals propagating from one block to the other. Existing fault injection tools offer a very limited choice of fault types with no automated support for fault injection and scalable experimentation. To overcome these limitations, we introduce FIM that supports automated fault injection and mutation in Simulink models with richer types of faults and mutation operators. FIM allows to control the activation of the faults and the fault parameters as well as restrict the fault injection space. FIM has three important parts: a fault injection library, a fault injection component, and a fault configuration component. As initial inputs, the user specifies a system under test, fault list, that is a list of desired faults, and an output directory. FIM supports two modes for injecting faults: single model mode and multi-model mode. In single model mode, the fault injection component creates a copy of the original model and injects all faults in the single copied file. In the multi-model mode, it creates multiple copies of the SUT and one fault is injected per model copy. Fault injection in single model mode allows the user to investigate the simultaneous effects of multiple faults. However, the size of the model is large. On the other hand, in the multi-model mode, FIM creates small-sized models that are easy to visualize and debug. After fault injection, FIM generates a fault table with a detailed description of the injected fault blocks. After injecting faults, the user can select the fault blocks to be activated and configure the fault parameters in accordance with the user-specified fault enable list. The fault injection library consists of customized blocks for different types of faults and mutation operators listed here. The fault blocks have different user configurable parameters, including a flag to control the activation of the fault block, a parameter to specify the time of fault occurrence, fault effect which governs the time of fault persistence. FIM supports two fault effects: infinite time, that is the fault persists till the end of the simulation, and constant time, that is the fault persists for a specified duration corresponding to the parameter fault duration. Fault value controls the fault amplitude. Operator number is used to select a relevant operator from a predefined list. We now present a step-by-step demonstration of FIM on the Simulink model of the aircraft elevator control system, an industrial benchmark from the aerospace domain. Let us start with injecting faults in the single model mode. We use the function FISingle, which has two arguments: the name of the configuration file and the name of the output directory. The configuration file is stored in the configuration folder and consists of the name of the model constants and thresholds, the folder in which the model is saved, and the fault list. The fault list is stored in the configuration folder and has different fields to specify the fault injection space and the type of fault to be injected. Level final specifies the hierarchy depth of the SUT. Other fields include the source or the import name, the destination or the output name, the name of the parent block, and the type of the fault or mutation. After execution of the command, FIM creates a copy of the original model and starts injecting the faults in the copied file. Once all the desired faults are injected, the fault injection results are stored in the specified folder in the form of a fault table The details include the name of the faulty model, the name of the faulty block, the name of the parent block in which the fault is injected, the type of the fault or mutation, and full details of the source and destination along with their port numbers. Such a detailed description allows to locate the injected fault block in the model. For example, the faulty block offset 1 is injected in the model aircraft copy in the left control loss with the source sum and the destination as gain, and the port numbers of the source and destination blocks is 1. We can use this information and check the mutated model to identify the fault block offset 1. We observe that the faulty block offset 1 has been injected between the lines connecting the source and the destination with their respective port numbers 1 and 1. After injecting faults, we configure the fault blocks. Let's say we want to turn on the fault blocks 1 and 38 and set the fault parameters. We use the function fcsingle along with the configuration file, the output directory, and an additional argument specifying the fault enable list stored in the configuration folder. It includes the list of fault blocks to be activated, which are uniquely identified by the block number and the fault parameters. After the execution of the command, the selected fault blocks 1 and 38 are activated and configured for the specified parameters. We can check the specifications in the model. We can see that the block offset 1 has been activated while remaining blocks are deactivated. The fault injection is turned off in other cases. To inject faults in the multi-model mode, we use the function FIMulti, specify the configuration file and the output directory. After the execution of the command, FIM creates multiple copies of the model and injects one fault per model copy. After fault injection, the results are stored in the specified output directory. To configure the fault blocks injected in the multi-model mode, we use the function fcmulti and specify the configuration file, the output directory, and the fault enable list. After the execution of the command, the fault blocks are activated and configured in their respective model copies. We introduced FIM for automated injection of faults in Simulink. Its implementation is publicly available. I'll be happy to get your questions on email. Thank you.